Hi, this is Mrs. Basin. In this screencast, we're going to talk about naming ionic compounds that have multiple charge metals. So the rules for naming compounds with multiple charges are very similar to the rules for naming with single charges. The difference is you have to specify which ion you have for the metal. So you still have the cation named first, or the metal named first, the anion or the non-metal named second. You still have IDE on the end of the anion. And again, like I said, the difference is that when you name the cation, you use the name of the element, but then you also have to include a Roman numeral to indicate what the charge on that particular atom is. And that is because, like we saw in the activity we did in class today, some atoms can form more than one ion. So if it forms more than one, so if it's one of these multiple charge metals, like iron is here, iron can be a +2 or iron can be a +3. So when we write the name for a compound that has iron in it, we have to use a Roman numeral to specify whether that is iron 2 in the compound or iron 3. And then, like we said a minute ago, the anion is still named by taking the root and adding IDE. So really the only differences for these were including a Roman numeral in the name. So here's a couple examples. This shows you iron 2 versus iron 3, copper 2, copper 1, cobalt 3, cobalt 2, etc. And if you look through that list, you can see some. The other thing you might notice here is there was an older naming system, and you still sometimes will see this on bottles of chemicals, where instead of using iron 3, like in this example here, and using the Roman numeral, they used the word ferric, or for iron 2, the lesser of the two charges, they used an OUS ending and called it ferrous. But we don't use this way anymore. We use this systematic name with the Roman numerals. So let's look at a couple example problems. So our first one, I'll go ahead and put all these on here. All right. So our first one is CuCl2. So we still use the name of the first element. So we're still going to start this with copper. And then the ending is still chloride. But because copper is a multiple charge metal, and I'll give you a list of those for reference, we have to include a Roman numeral to tell us what the charge is. And the way you figure out which copper it is you have to remember that concept that we talked about in class is when the overall charge on this has to equal 0. So we know chloride is a -1, so for this to balance out to 0 the way it's written, this would have to be copper 1 chloride. Okay, if we look at our next example, we still have CuCl2, so it's still going to be copper chloride, but this time, instead of copper 1 chloride, now it's going to be copper 2 chloride. There's two chlorides, which are both -1s, so that gives me a charge of -2. So for this to balance out and equal 0, that means that this copper had to have been a 2. So we name this copper 2 chloride. Next example, I have iron and oxygen. So this is going to be iron oxide. Then to figure out my charge, oxygen we know is a -2 because our anions are always going to have the same charges. They only have single charges. So on this side, my oxygen contributes a -6. So over here, for iron, for this to balance out to 0, this iron would have to be a +3, because +3 times 2 gives me a +6. So this would be iron 3 oxide. Next example, manganese oxide, with my Roman numeral in here. So oxygen I know is a -2. So to balance this out, that means manganese would have had to have been a +2. So this is manganese 2 oxide. My last one, lead chloride. And then to include my Roman numeral, chlorine's a -1, and there's 4 of them. So to balance that charge out and make it 0, lead would have to be a +4. So this is lead 4 chloride. And again, the only time we need these Roman numerals is if we're dealing with metals that can have multiple charges. Okay, so if you want to take a minute and do some practice problems and come back and check them. Okay, so we're looking at cobalt, chloride, so chlorine again is a -1. There's 3 of them, so that means cobalt has to be a +3 to balance it out. So that's where our Roman numeral 3 comes from. My next one, copper, iodide. And again, to get a Roman numeral, iodine's a -1, so to balance that out, copper has to be a +1, so this is copper 1 iodide. My next one, tin, bromide. And then go back and get my Roman numeral, bromine's a -1, there's 4, so tin has to be a +4, so my Roman numeral indicates that. My next one is iron 2 oxide. Oxygen we know is a -2, so to balance that, since there's 1 of them, this is iron 2. And then the last one, lead 2 sulfide. And again, we know that because sulfur is a -2, so to balance the charge, lead has to be a +2. Okay, last thing we want to look at is how to write the formulas for compounds that have multiple charged metals. So to do this, we still are going to cross our charges like we did before, but to find out what the charges are for those multiple charged metals, we have to look at the Roman numerals. So what the Roman numeral is going to do is it's going to tell us the charge of the metal. So instead of using the periodic table to get those charges like we've done with the other ones, if they're only single charge metals, these, the charge comes from the Roman numeral. And then to get the anion charge, we still just use the periodic table like we did before. So cobalt is a +2 because of this Roman numeral right here. Chlorine is still a -1. So when we cross those, we get CO, Cl2. My next one, copper, is a +2. Sulfur is a -2, and that comes from my periodic table. Copper's charge comes from here. Crisscross those, the 2's cancel out, I end up with Cus. My next one, lead, Pb, lead 4, so it's a +4. Iodide is a -1. Crisscross those, and I get PbI4. Then my last one, tin, is a 4, +4. Oxygen is a -2, so I crisscross those, and I get SN2O4, which I can reduce to SNO2. So again, when you're writing the formulas, the charge of the metal now comes from the Roman numeral, so that belongs to those metals. And then the anion charge, the second piece of this, that just comes from the periodic table, the same way you got those charges for just the regular single charge metals.